Hello everyone. Today we will like to study the chapter 3 of machine learning. The title of this chapter is Inductive Decision Tree Learning. So the first section is basic concept of decision trees. So a decision tree is a tree-like structure where each internal node represents a feature, branches represent the feature value, and leaf nodes represent the classification outcomes or regression values. The process of building a decision tree involves the recursively selecting the optimum feature to split the data until stopping criterion is met. Key concepts include node and leaves. Nodes are decision points where leaves are the final classification or regression result. Path and rules. Path is from the root node to leaf nodes represent decision rules. Information gain, a metric used to select the optimum feature for splitting. Entropy, a measure of data uncertainty where lower entropy indicates lower uncertainty. ID3 diagram. The ID3 Iterative Dichotomiser 3 algorithm is a classic decision tree construction algorithm that selects the optimum splitting feature based on information gain. The main steps of the ID3 algorithm include calculate the information gain. For each feature, calculate its information gain and select the feature with the highest information gain for splitting. Consult tree node. Create branch node based on the optimum feature and recursively build subtrees for each branch. Stopping criterion, stopping splitting when all features have been used or when all samples belong to the same class. The next chapter is the C4.5 algorithm. The C4.5 algorithm is an improved version of the ID3 algorithm, addressing some of the ID3's limitations, such as the inability to handle continuous feature and missing values. The main features for the C4.5 algorithm including handling continuous features, discrete continuous features by splitting them using threshold, information gain ratio, use information gain ratio instead of information gain to avoid bias toward the features with many values, pruning strategy, performing pre-pruning and post-pruning during tree construction to reduce overfitting, handling missing value, deal with missing features values through probability distribution. CART algorithm. The CART classification and regression tree algorithm is a decision tree algorithm that can handle both classification and regression problems. The main features of the CART algorithm include Gini index, used as a splitting criterion for classification tree, measuring the purity of the dataset. Mean square error, used as a splitting criterion for regression trees, measuring the deviation between predicted and actual values. Binary tree structure, called generate binary trees, where each node has only two children. Pruning strategy, use cost complexity pruning to reduce tree complexity and improve generalization ability. Pruning of decision trees. Pruning is a method used to reduce overfitting in decision trees by removing unnecessary nodes, simplifying the mode, and improving generalization ability. Pruning methods mainly include pre-pruning, stop splitting, during tree construction by setting stopping criterion, For example, information gain threshold number of samples per node, post-pruning, prompt subtrees that contribute little to the model after the tree is fully constructed. Pruning strategies. Common strategies include cost complexity pruning, reduced error pruning, and minimum error rate pruning. Evaluation criteria. Use cross-validation or level one out validation to assess pruning effectiveness and select optimum pruning parameter. So now I would like to give you a Chinese explanation. 接下来我们要把这个有关归纳决策树学习的这个部分内容用中文再跟各位来解释。那首先是决策树的基本概念。决策树是一种树形的结构，那其中内部的每一个节点都代表一个特征，那一个分支就代表特征值，那叶节点就代表分类结果或者是回归值啊。决策树的构建过程是递归的选择最优特征来进行分裂，直到满足条件为止。那么以下是一些关键的概念。首先是节点跟叶子啊，节点就是决策点，叶子就是最终分类或回归的结果。其次是路径跟规则啊，从根节点到叶节点的路径代表一条决策的规则。那信息的增益就是用于选择最优分裂特征的度量方法。那就是商，就是衡量数据不确定的度量方法。商越小，不确定性就越低。那么其次是 ID3 的算法。ID3 就是 Iterative Dichotomiser 算法，这是一种经典的决策树的构建方法。那么基于信息增益选择最优分裂特征ID3 的算法主要的步骤包括：第一个是计算信息的增益，对于每一个特征，我们计算它的信息的增益，然后选择信息增益最大的特征进行分裂。其次是构建树节点，那数据最优特征创建分支节点，那递归的对每个分支继续构建子树。那么停止条件就是当所有特征都已经使用，或者所有样本都属于同一类时，就停止再继续分类。那其次是 C4.5 算法。C4.5 算法是 ID3 算法的改进版本它解决了 ID3 的一些局限性，例如说它无法处理连续的特征跟处理缺失值等那 C4.5 的算法的主要的特点就包括：第一个是连续特征的处理，它通过阀值分裂将连续特征离散化其次是信息的增益率，它使用信息增益率来代替这个信息的增益，那避免偏好多于就是多值特征的问题再过来就是减资策略，在构建就是的构建这一个过程里面那么进行预减资跟后减资来减少过拟合再过来就是处理缺失值，那通过概念的分配来处理缺失特征值。那接下来是有关 CART 的算法。CART 就是 Classification and Regression Trees， 它是一种算法，是一种既能处理分类问题，又能处理回归问题的一个决策树的算法。那么 CART 算法的主要特点就包括：第一个是基尼系数，它用在分类树的分类标准来衡量数据集的纯度；其次是均方误差，就用在回归树的分裂标准，那衡量预测值跟实际值的偏差再过来是二差数的结构，那 CART 生成的是二差数，每个节点仅有2个子节点。再过来就是减资策略通过成本复杂度的减资的方法来减少这个树的复杂度，来提升它的泛化能力。那么决策树的减资是什么呢？所谓的减资就是减少决策树过拟合的一种方法 那通过删除一些不必要的节点，简化模型，提高这个泛化的能力。那减支数的方法主要包括：一是预减支在树构建的一个过程里面，我们通过设定停止的条件，例如说信息增益的阀值、节点的样本数等等，来提前停止分类。其次是后减支，那么在树构建完成的时候，通过评估每一个指数的贡献，减去那些对模型贡献较小的指数。再过来就是减支策略，那么常见的减支策略包括代价复杂度的减支，那误差减少减支跟最小错误率的减支。那么再过来就是有关就是评估的一个标准，就是通过交叉验证或者是留下一个验证来评估减支的效果，来选择最优的减支的一个参数。好的，那我们今天的课程呢就上到这边感谢大家的收听。